Welcome back. This is Nick Agriam. In this video, I will be discussing composite functions. And the basic of composite functions is that we have two functions, or three, and then these functions, we're going to put one of them within another functions. So the notation for composite function is this one or this one. This is what I'm going to use here in this series of videos. Okay, consider, says here, we have f of x is equal to x raised to 4, and then g of x is equal to 2x plus 3. And if we're going to find the composite function of x, that means we have f of g of x. Then we're going to compare that when we have g of the composite function of g and f. That means the function of the g function of f. That's it. Okay, we're going to compare these two later, and then we can see what we can derive from the result, what observation we can derive. Okay, let's start. We have now f of g of, sorry, it should be red, not gray. F of g of x. Our f of g of x now is 2x plus 3. But our f of x is x raised to 4. So this is our x now, the whole thing, 2x plus 3 raised to 4. That's now the composite function of g, f, and g. Now, we'll take a look on the composite function of g and f. F of x. Now, f of x is x raised to 4. And then, our g of x is 2x. Then we have 2 times x raised to 4 plus 3. And that is 2x raised to 4 plus 3. As you can see now, the results are not the same. Now we can take generalization in general. F, the composite function of f to g of x is not equal to the composite function of g to f. They are not equal. Okay, let's take an example, or another example. We're going to take a look at the composite function of g to f to x. So f of g of x. So our g of x is this one, 3 minus 4x. And our f of x is this one. So we have 2 times 3 minus 4x plus 1. Then we have 6 minus 4x, 8x plus 1. Then we have 7 minus 8x. That's a composite function. For b, g of f of x is equal to our g of f of x is 2x plus 1, and then our g of x now is 3 minus 4 times 2x plus 1. Okay, then we have 3 minus 8x minus 4. Then we have negative 8x minus 1. So they are not the same again. More examples here. Okay, we have f of x is equal to 6x minus 5, and g of x is x squared plus x. Then we need to find g of f of x, where x is equal to negative 1. Okay, negative 1. Okay, and then we have our we have now our f of x, f of negative x, so 6 times negative 1 minus 5. Then we have g of negative 11. That's negative 6 minus 5 is negative 11. Then we have our g of x now, this one. So we have negative 11 raised to 2 plus negative 11. Then we have 121 minus 11, 0, 1, 1, 110. Okay, the next one is our b, maybe another pen, another color. We have f of 0. So our f of 0, we have 6 times 0 minus 5. Then we have f of negative 5. And then one more time, we use the same, but this time our value is negative 5. So we have 6 times negative 5 minus 5. Then we have negative 30 minus 5. Then we have negative 35. Another example, we have f of x is equal to the square root of 6 minus x, and the g of x is equal to 5x minus 7. Then we're going to find, for a, we're going to find g of x. So our g of x, our g of x is 5x minus 7. And we do that one more time. Our 5 times our g of x is that whole thing. We have 5x minus 7. And then we have minus 7 there. So we have, if we multiply to both terms, we have 25x minus 35 minus 7. Then we have 25x minus 42. Okay, for our b, we're going to find f of g of 1. So our f of g of 1, our g of x is 5 times 1 minus 7. That's our g of 1. So we have f of 5 minus 7, so f of negative 2. Now f of negative 2, f of negative 2 is square root of 6 minus negative 2. So we have the square root of positive 8. That's it. Or we have square root of 4 times 2. Then we have times 2. And we have 2 square root of 2, if you want to simplify. The next is g of f of 6. So we have g of f of 6 first. F of 6, we have this one. So we have square root of 6 minus 6. then we have g of 0. So our g of 0, we have 5 times 0 minus 7, and we have negative 7. Okay, in my next video, I will be discussing sign diagrams. It's very important also when you start with your calculus. And I hope you learned something in composite functions, and if you like what I am doing, please like it or subscribe. And thank you for watching. Have a nice day. See you next time.